So hi everyone, my name is Manvi Gumba and this is my assignment 4 for Comp3132 course. And basically in this video I'll walk you through the convent model where I'll demonstrate the overfitting and apply multiple techniques to reduce the CIFAR data set. So let's begin. So first of all, I have initialized my name, like commented my name over here, like Manvi Gumba with my student ID. And then let's begin. So basically the first part contains, I choose the CIFAR 10 dataset which contains 60,032 into 32 color pixel images in 10 different classes such as airplanes, cars, etc. So I loaded the dataset using the TensorFlow. Over here, normalize the pixel values from ranging from 0 to 1 and split into training, validation and test datasets. To prepare the validation, I manually split the 10,000 images from the training data. This gives us around 40,000 for training, 10,000 for validation, and then 10,000 for testing. Next, we have overfitting, which is like to stimulate the overfitting. I built the convolutional neural network with large number of filters and neurons. This model helps too many parameters for a relatively small data set, which causes the model to memorize and training data instead of generalizing well. After training the model for 10 epochs, which is still loading at the moment over here, so it's gonna take some time, so I'm just making the video as of now. And then the training accuracy was very high, but the validation accuracy was much lower, and this is clear sign of overfitting, as you can see over here for from one epoch. And I also plotted the graphs for the training and validation for loss and accuracy. As you can see, the loss for the validation starts increasing while the training loss keeps decreasing, which confirms that it's overfitting. Next, we have the reducing the overfitting, which is like to basically to reduce the overfitting, I applied the three key values over here, which is L2 regulation. I added the L2 regulation to the convolutional and dense layers. This penalizes the large weights and encourages the model to learn simpler patterns. And I added the dropout layer after the pooling layers and dense layers. This randomly disables the fraction of neurons during the training, which forces the network not to rely on one neuron but prevents the overfitting. Data augmentation, basically I use the image generator to apply the random transformations like rotation, shifting, flipping, and this helps the model to generalize better by seeing the new variations of the images during the training. So I train new model for 30 epochs over here, since the regularization model can handle more training without overfitting. Then we have our part 4. I plotted the 4 graphs, 2 for overfitting and then 2 for regularized model. In the regularized model graphs, you can see that the gap between the training and the validation accuracy is much smaller, which will be soon visible over here because it's loading and it's taking too much time. Also, the validation loss decreases steadily, indicating the better generalization, and the regularized model achieved improved accuracy and reduced the overfitting, which showing that these techniques were very effective over here. So basically the projects demonstrate how a model can easily overfit too many parameters and how we can reduce the overfitting using the L2 regularization, dropout and data augmentation. Thank you very much.